Hey guys, Mr. Backerberg here. In this video, we're going to look at solving two linear equations simultaneously. As we're looking at solving a system of linear equations, there are several different ways that you've learned how to do so. One way would be using substitution. Another way would be using elimination. You've learned graphical methods for solving, and we've also learned how to use a matrix to help us solve a system of linear equations. So in this first example, we're going to solve a system of linear equations using substitution. So we've got the equations 3x minus 5y equals 39, and our other equation says 2x plus 3y equals 7. Now, in order to use substitution, we need to first isolate one of our variables in our equations. So I'm just going to work with the top equation, and I'm going to work on isolating the x. So the first thing I'm going to do is add the 5y over to the other side. So I'll get 3x equals 5y plus 39, but then I want to get rid of the 3 that's attached to the x, so I'm going to divide everything by 3, which is going to leave me with x equals 5/3 y plus 13. Now when I'm using substitution, I'm going to take this information right here, and because I know that's what x is equal to, in my other equation, I'm going to plug that stuff in for the x variable. So we get 2 times 5/3 y plus 13 plus 3y equals 7. Distributing that 2, well, 2 times 5/3 is 10/3 y. 2 times 13 is 26. And then we have plus 3y equals 7. I'm going to combine those y's. In order to do so, I'm going to need common denominators. So 3y becomes 9/3 y, and if I combine that with the 10/3, I get 19/3 y. I'm going to take this 26 and subtract it over to the other side right away, and if we do that, we're going to get negative 19. In order to get y alone, we're going to have to get rid of this 19/3, so I'm going to multiply it by the reciprocal, which is going to be 3/19. So that's going to leave me with a y value of negative 3. Now I'm not quite done because I also need to find an associated x value that goes with this y value of negative 3. So I'm going to take this negative 3 that I just got for this y value. I'm trying to solve to find what x is. So I'm going to use this equation right here where we solved to get x alone, and I'm going to plug in the negative 3 for the y. So that's going to say x is equal to 5/3 times negative 3 plus 13. Well, if we take 5/3 times negative 3, that's going to give me negative 5. And then we have to add 13 to that. So that's going to give me an x value of 8. So the ordered pair answer for this system of equations is the point 8, negative 3. Taking a look at this example, we're going to solve the exact same system, but we're going to use elimination this time. Since we're solving the exact same system, we should get the exact same answer, otherwise something went wrong. When you're using elimination, the goal is to eliminate one of those variables so that you're down to just a one variable equation, which is a whole lot easier to solve. As we're looking at these two equations, I'm going to focus on the x's. We want to get those to cancel out. So seeing that we have coefficients of 2 and 3, I'm thinking that we're going to be working towards 6, but in order to get them to eliminate, we need them to be opposites of each other. So what I'm going to do is take this top equation and multiply everything in there by 2. So that's going to give me 6x minus 10y equals 78. Now to cancel out with a 6x, I'm going to need negative 6x. So I'm going to take this bottom equation and multiply by negative 3. So that's going to give me negative 6x minus 9y equals negative 21. Now what we're going to do is add these two equations together. Because those x's are opposites of each other, they're going to cancel out. If we take negative 10y and subtract 9y, we're going to get negative 19y. And if I take 78 minus 21, I'm going to get 57. And then we want to get y alone, so to get rid of this negative 19 that's attached there, we're going to have to divide by negative 19, which gives me a y value of negative 3. And that should make sense because that's what we got for our y value on the previous example. Now we do still need to solve for x, so now that we know that y is -3, we're going to go into one of our equations, plug that y value in, and then solve to figure out what x is going to be. I'm going to use the bottom equation because that has smaller numbers in it. Plugging in the y value of -3, this is going to say 2x plus 3 times -3 equals 7. Well, 3 times -3 is -9, so we get 2x minus 9 equals 7. Add the 9 over to the other side, and we get 2x equals 16. Divide by the 2, and we get an x value of 8, which again matches up with what we just got on the previous example. So the ordered pair answer, again, is still 8, -3. Taking a look at this example, we're going to solve that exact same system again, but this time we're going to use graphing. Now we are going to use our calculator to help us out, so we're going to have to get these equations written in y equals form to be able to type them into our calculator. So looking at this top equation, the first thing I'm going to do is subtract that 3x over to the right-hand side. So we're going to get -5y equals -3x plus 39, and then I'm going to divide everything by -5. So we'll get y equals 3/5 x minus 39/5. Now I'm just going to leave those in fraction form since they don't necessarily simplify down nicely. Now if we look at our second equation, we want to do something similar and get y alone. So I'm going to subtract the 2x over to the right-hand side. So we'll get 3y equals -2x plus 7. Dividing everything by the 3, we're going to get y equals -2/3 x plus 7/3. And again, I'm just going to leave those in fraction form since they don't simplify down nicely. Now what we need to do is get our calculator fired up. In my calculator, I already have both of those equations typed in. So I've got the y equals 3/5 x minus 39/5, and I've got the y equals -2/3 x plus 7/3. I'm going to do zoom 6 to get my nice window, and we can see our two lines being graphed out. What we're looking for when we're solving graphically is the point where our lines intersect. So we're focusing on this point right here. To find that intersection point, I'm going to hit second trace, and option number 5 says intersect. Since we're just dealing with two equations, we don't have to worry so much about the first curve and the second curve and that stuff. So I can just hit enter, enter, and then one more enter, and it'll tell me that that intersection point has an x value of 8 and a y value of -3, which matches up with what we've been getting. In our last example, we're going to solve that exact same system again, but this time we're going to use a matrix to help us out. The first thing that I want to do is take this system of equations and get it written in its matrix form. So my top row is going to be 3, -5, 39. My bottom row is going to be 2, 3, 7. So there's our matrix. Now we're going to fire up our calculator to let it do most of the work for us. So in your calculator, to find the matrix options, right above your X with a little -1 power on it, your inverse button, it says matrix. So I'm going to hit second matrix. I've already got it plugged in for matrix A. What you'll need to do is arrow over to edit, select matrix A. It's a 2x3 matrix, 2 rows, 3 columns. The top row was 3, -5, 39. The bottom row is going to be 2, 3, 7. So you'll get that entered in. We'll go second, quit. Then we're going to go back into our matrix menu. So second matrix, arrow over to math, and we're going to arrow down until we find the option that says RREF. That's reduced row echelon form. That's how we solve a matrix. And go back into your matrix options and select matrix A, since that's where we have our information entered in. We hit enter, and the right-hand column tells you what those values should be. The top number is your X, the bottom number is your Y. So that's the point 8, -3 again, which matches up with what we've been getting this whole time. That's going to be it for this video. Thanks for watching.